So in this session, we will discuss about the combination of errors in different operations, like the error in sum, error in subtraction or error in the difference, error in product, error in division, etc. Let's first take error in the sum. Error in the sum. Let's take two variables, let's say a and b. This a and b be any two variables, and we have a relation, let's x is equal to a plus b. This x is another variable which is equal to the sum of these two variables a and b. We always represent the error in the variable using delta, like the error in a is delta a, and error in b is delta b. We call that as absolute error. That is delta n and delta b be the absolute errors in the variables a and b. Clear? Now we are interested in finding the absolute error in x. Let's assume delta x be the absolute error in x. So we always write x plus or minus delta x. That means the quantity plus the error, which can be plus or minus. All absolute errors can be plus or minus. So we represent x with including the error as x plus or minus delta x, which is equal to a plus or minus delta a, that is the absolute error in a, plus this plus b plus or minus delta b. Clear? We can put in that in brackets because we represented a including the absolute error. Similarly, that b also. Now we can simplify this. We have x plus or minus delta x is equal to, if you remove the bracket, you get a plus or minus delta a plus b plus or minus delta b. You can write these two variables together, like x plus or minus delta x is equal to a plus b. Now these two terms together, you can write that as plus or minus delta a plus or minus delta b. Clear? Now if you look at this one, this is actually x. Clear? So you can write x plus or minus delta x is equal to, this can be written as x. If you take the plus or minus outside the bracket, you can write like this, delta a plus delta b. Clear? You can cancel this x. Now the final expression is plus or minus delta x is equal to plus or minus delta a plus delta b. That means we always write as the absolute error in x as the maximum possible error. So we have to consider the different combinations of delta a and delta b, which means delta x can be, there are four possible cases. One is delta a plus delta b itself. Second one, delta a minus delta b. The third case will be, this time delta a is negative, delta a plus delta b. This will be minus delta a minus delta b. Or if you consider if these all cases, you can clearly see that this one is the maximum possible error, that is delta a plus delta b. If you can if you let's take delta A equal to 1 and delta B is equal to, let's say, some 2. Just take the numbers, any numbers, and if you put all these values in here, these values in here, you will get delta A plus delta B. 3 is the maximum possible value. For example, here it will be 1 plus 2, which is 3. Here it will be 1 minus 2, which is equal to minus 1. Here it will be minus 1 plus 2, which is equal to 1. Here it will be minus 1 minus 2, which is equal to minus 3. So of all these 4 values, 3 is the biggest one or the largest error. So you can conclude that the maximum possible error in delta x will be delta x is equal to delta A plus delta B. So this is the expression for the maximum possible error in sum of the two numbers. Now let's consider an example, that is, let's take a steel bar. Let's represent its length, let's say L1, which is equal to, let's say, 3 meter, 3 plus or minus 0.01 meter. That means the measurement including the absolute error. Let's call this as A steel bar A. We have another steel bar of cross section greater than the first one. Let's call that as B, and let's say its length L2 be some 4 plus or minus 0.02 meter. Now we want to find, if I join this A and B, or if I weld here, what is the total length of the new bar? The new bar will be somewhat like this. This portion is A, this portion is B. Clearly the total length L will be, total length of the new steel bar will be L1 plus L2. Clear? So we can write this L1 is equal to this one. This let's take for our convenience L1 be this 3, and the error in delta L1, the error in the first length, we can take that as 0.01 meter. Here also you have to put the unit. L2 is 4 meter, and delta L2 is equal to 0.02 meter. We first have to find L, which is equal to L1 plus L2. That is, you have to add these 2, 3 plus 4, which is equal to 7 meter. Now the maximum possible error in the sum of the length delta L, we already derived that. We have delta x equal to delta A plus delta B. Here it will be delta L1 plus delta L2. Clear? So that is equal to 0.01 plus 0.02, which is equal to 0.03 meter. So this length L can be represented as 7 plus or minus 0.03 meter. Clear? So this is the final representation of the total length of these two rods or these two bars when joined together, include with the correct error limits. Clear? Now let us discuss error in difference of two variables. Error in difference. Let x be the variable which is related to two other variables like a and b, as x is equal to a minus b. We already know delta a, like in our last example, delta a is the absolute error in b and delta b be the absolute error in b. So when you write the variable x including the absolute error, you can write it as x plus or minus delta x is equal to a plus or minus delta b. That means a plus or minus delta a. That means the measurement a including the absolute error minus b plus or minus delta b. Now we can write this as x plus or minus delta x is equal to, you can remove the brackets, so it will be a plus or minus delta a, minus into plus is minus b. So minus into plus or minus, this minus and this plus will become minus, and this minus and this minus will become plus. So it will be minus or plus delta b. So this will be x plus or minus delta x is equal to, you can combine this one, which is a minus b. Now plus or minus delta a. You can write this minus or plus in like plus or minus itself. Clear? See, plus or minus is equal to minus or plus. Both are the same. So x plus or minus delta x is equal to, this one you know it is x itself. So x plus or minus, if you take the plus or minus outside, you can write this as delta a plus delta b. Now cancel this x. So delta x is equal to, plus or minus delta x is equal to plus or minus delta a plus delta b. Delta a plus delta b. So this is the final combination. So like we discussed before, we have four combinations. Delta x is equal to delta a plus delta b, delta a minus delta b, minus delta a plus delta b, and minus delta a minus delta b. So of these four combinations, this one is the maximum possible absolute error. So the final expression will be delta x is equal to, that is the maximum possible error in the difference of two variables, equal to delta a plus delta b. Clear? So this is the final expression. Now let's discuss a problem relating this combination, that is error in combination in difference of two variables. Suppose I take the temperature at a place, let's say T1 is equal to, let's take 30 plus or minus 0.4 degrees Celsius. Let this be a temperature at a place. We have another temperature at that same place after some time. Let's take 28 plus or minus 0.6 degrees Celsius. So we want to find the difference in temperature. So the difference in temperature, let's take T. We write that as T1 minus T2. Now we have, like we discussed before, T1 is equal to 30 degrees Celsius. Delta T1 is equal to 0.4 degrees Celsius. Similarly, T2 is equal to 28 degrees Celsius and delta T2 is equal to 0.6 degrees Celsius. First you have to find this T. That T will be, that will be the difference of these two temperatures. So 30 minus 28, which is equal to 2 degrees Celsius. Now we know the absolute error always add. So we proved that before. We just proved it, that is delta x is equal to delta a plus delta b. So delta t will be delta t1 plus delta t2. So that is equal to 0.4 plus 0.6, which is equal to 1 degree Celsius. Therefore, the temperature with including the error limits will be 2 plus or minus 1 degree Celsius. Clear? Now let us discuss the error in product of two variables, that is error in the product. Product means the multiplication of two variables. Suppose we have a variable x which is defined as the product of two other variables a and b, where delta a be the absolute error in a and delta b be the absolute error in b. So we have, let's assume delta x be the absolute error in the variable x. So writing this variable along with the absolute error, we can write that as x plus or minus delta x is equal to a plus or minus delta a times b plus or minus delta b. Clear? Now if you multiply on the right hand side, you will get x plus or minus delta x equal to a into b is ab, a into plus or minus delta b is plus or minus a delta b. Now plus or minus delta a into b is plus or minus b delta a. Now plus or minus into plus or minus is again plus or minus delta a into delta b. Clear? Now we have delta a as absolute error in a is very small, and also the absolute error in b is also very small. So the product of these two numbers is, we can conclude that as approximately equal to 0. So we can remove this one. This turns 0. So x plus or minus delta x will be, you know, this AB is x itself. Clear? So x plus or minus, you can take this plus or minus outside. Now it will be a delta b plus b delta a. This will become 0. Now you can cancel this x. So plus or minus delta x is equal to plus or minus a delta b plus b delta a. Now what I am doing is, I am dividing this whole equation 1 with x, that is plus or minus delta x by x is equal to plus or minus, you have to divide this each term with x. So a delta b by x plus b delta a divided by x. So this will be plus or minus delta x by x is equal to plus or minus a delta b by, but you know x is equal to ab. So here it will be ab plus b delta a by ab. You can cancel this a and this b. So the final expression will be delta x by x is equal to plus or minus. You can write this one first. Clearly, p plus q is q plus p, it's q plus p also. So this is equal to delta A by A plus delta B divided by B. See, there is only delta A by A here, here delta B by B. Now this is the final expression, and we want to find the combination of delta A by A and delta B by B. So delta X by X can take these four possibilities, that is delta A by A plus delta B by B, that is the first combination. Now delta A by A minus delta B by B minus delta A by A plus delta B by B, and the last one, both of these variables are negative. Of these four conditions, this one is the greatest possible error. So we can conclude that delta X by X is equal to delta A by A plus delta B divided by B. Clear? So that is the maximum possible error in the product. We can, this is not the absolute error, this is called the relative error or the fractional error. That is delta X by X is called the relative error or fractional error in the variable X. So the fractional error in X is equal to sum of the fractional errors in A and B. Clear? Now let us consider an example. We have Ohm's law. Ohm's law relates the potential V to the current and resistance of the conductor. We have potential across the ends of a conductor is the product of current flowing through the conductor into resistance. Suppose we have the current in the circuit as 2 plus or minus 0.04 ampere. That is the measurement of current with error limits. Let's say resistance in that circuit be 8 plus or minus 0.16 ohm. Now we want to find the voltage with error limits. We know V is equal to IR. You can find that this is the V, so which is 2 into 8, which is equal to 16 volt. Now we know the relation, this is the product of two variables. So the fractional error in the voltage will be the fractional error in the current plus the fractional error in the resistance. So this is equal to, so delta I here is 0.04 ampere. I in here is 2 ampere. Similarly, R here is 8 ohm. Delta R is equal to 0.16 ohm. So substituting, you get 0.04 divided by 2 plus 0.16 divided by 8. So delta V by V will be, this is equal to 0.02 plus 0. This is also 0.2. So which is equal to 0.04. The fractional error in voltage is 0.04. And you know delta V, if you take this V to the right, which is equal to 0.04 into V. But we already found 0.04 into V is 16. So multiplying 4 into 16 is 64. So it is equal to 0.64 voltage. So the final voltage is equal to 16 plus or minus 0.64 volt. Clear? So this is the final expression of the voltage with the error limits. Clear? Now let us discuss about the error in quotient or let's say division of two variables. Error in quotient or division of two variables. Suppose we have a variable x which is related to a and b by x is equal to a divided by b. Let delta a and delta b be the absolute errors in a and b, and let's say delta x be the absolute error in x. Delta a and delta b the absolute errors in a and b. Similarly, delta x is the absolute error in x. Now, if we write this variable with the error limits, we can write this as x plus or minus delta x is equal to a plus or minus delta a divided by b plus or minus delta b. Clear? So this can be written as x plus or minus delta x. Now if you take a from here, a, then you have to put the bracket. If you remove a from here, it will be 1 here, plus or minus. This can be written as delta a by a. If you multiply a into 1 is a into delta a by a is, this a and a will get cancelled, it will be delta a. Clear? So divided by, similarly you have to take the b from here, b into 1 plus or minus delta b by b. Clear? Again, if you take x from here, x into 1 plus or minus delta x by x. That is x into 1 is x, x into delta x by x, this x and x will get cancelled. So it will be delta x itself. Equal to, you can write this as a by b into 1 plus or minus delta a by a divided by 1 plus or minus delta b by b. Now you know a by b, we define that as x itself. So x into 1 plus or minus delta x by x is equal to, this is equal to x into 1 plus or minus delta a by a into, you can take this to the numerator. What you have to do is, you have to put a minus 1 here, like 1 plus or minus delta b by b raised to minus 1. Clear? You know 1 by x is equal to x raised to minus 1. Clear? Now simplifying this, you can cancel this x. So 1 plus or minus delta x by x equal to 1 plus or minus delta a by a into, see, there is we have to simplify this. We have 1 plus x raised to n approximately equal to 1 plus nx, if and only x is very much less than 1. Clear? That is 1 plus x raised to 1 plus x whole raised to n is 1 plus nx if x is very much less than 1. But we know delta b by b is always less than 1, very much less than 1. So we can use this equation in here. Here the n is minus 1. Now this is equal to 1 plus or minus, in this minus 1 comes here as a coefficient, minus 1 into delta b by b. Clear? Simplifying this, you will get 1 plus or minus delta x by x is equal to 1 plus or minus delta a by a into, see, minus 1 into plus into minus 1. First write this 1. Plus into minus 1 is minus. Minus into minus 1 is plus. So this is equal to delta b by b. 1 plus or minus delta x by x is equal to, this plus minus of we already discussed, minus or plus is actually plus or minus. So 1 plus or minus delta a by a into 1 plus or minus delta b by b. Now if you multiply the right hand side, you will get 1 plus or minus delta x by x is equal to 1 into 1 is 1. 1 into plus or minus delta b by b is plus or minus delta b by b itself. Now plus or minus delta a by a into 1 is plus or minus delta a by a. Now plus or minus into plus or minus is again plus or minus. Plus or minus delta a by a into delta b by b. But we know delta a into delta b is approximately equal to 0 because both of these quantities are very much less than 1. So 1 plus or minus delta x by x is equal to 1 plus or minus, you can take this plus or minus as common. It will be delta b by b plus delta a by a. This term becomes 0. Cancel this one. So plus or minus delta x by x is equal to, you can rearrange this as plus or minus delta a by a plus delta b by b. Like we discussed before, we have 4 cases, that is delta a by a plus delta b by b, and delta, I'll write delta x by x has 4 possibilities, that is delta a by a plus, we already discussed this, but if you are focused only in quotient, you don't have to go back to other sections, you can only infer here itself. So delta a by a minus delta b by b these are the first 2 cases. Now delta minus delta a by a plus delta b by b minus delta a by a minus delta b by b. So these are the 4 possible cases. Of this one has the maximum possible error. So we say the fractional error, this is not the absolute error itself, this is called the fractional error or the relative error. The maximum relative error in x is equal to the maximum relative error in a plus the maximum relative error in b. Delta x by x is the fractional or relative error. In x. Clear? Now let us take an example. We have the density of a body. Density is always mass divided by volume. Now if I say the mass of a body is equal to, let's say, 4 plus or minus 0.08 kilogram, and the volume occupied by, or the volume of this body, this mass is, let's say, 2 plus or minus 0.04 meter cube. Now we want to find what is the value of density with the error limits. First, you know, density is equal to mass by volume. Here we already discussed m is equal to 4 kg. Error in mass is 0.08 kg. Similarly, volume of this mass is 2 meter cube. Error in the volume delta V is 0.04 meter cube. First find the density, which is equal to 4 by 2, that is equal to 2 kilogram per meter cube. That's the unit of density. Now we know the relative error in the density. This is a combination of error in quotient or division. So relative error in density equal to sum of the relative error in mass plus the sum of the relative error in mass and relative error in volume. This is equal to 0.08 upon 4 plus 0.04 upon 2, which is equal to 0.02 plus 0.02, which is equal to 0.04 kilogram per meter cube. That is the relative, don't write the unit in here because relative error has no unit. So delta rho by rho is equal to 0.04. Now the absolute error in density equal to 0.04 into rho. But we already found rho is equal to 2. So that is equal to 0.08 kilogram per meter cube. Absolute error has the same unit as that of the quantity itself. Now if you represent the density will be 2 plus or minus 0.08 kilogram per meter cube. Clear? So this is the final representation of density with the correct error limits. Clear?